Testing. Testing. 1, 2, 3. 1, 2, 3. Testing. Okay, ladies and gentlemen, it is time for our final lecture before what? Spring break. Imagine that. Imagine taking a break from game engines. I can't hardly imagine it myself. You know, during my spring break, I'm going to be working on game engine stuff. Not because I need to, just because I cannot get enough. Okay? It's just that much fun. In particular, I'm going to be working on the homework 9, so I actually do have to get to that at some point. Today, our mission is going to be to kind of get you a better feel for the kind of underlying C++ architecture of this kind of component-based model you're building in your engines, okay? And that is just the first part of it. We're going to talk about how to power up. Hey, excuse me. Hey, thank you. You can keep whispering, just keep it quiet. We are going to go under the hood a bit, and we're going to talk about the C++ side of things. How do you actually create new tables in C++? How do you communicate between C++ and Lua? How are you going to represent these components in your code base and work with them, iterate through them, manipulate them, store them, all that good stuff, okay? So if you've been a bit confused about how to begin on homework 7, hopefully this lecture will really help jumpstart you there, okay? First, we have a legendary engine, one that is no more, unfortunately. But this was an engine that you might have said was kind of the unity of its day. It was a cross-platform game engine that made a lot of things easy, across consoles even. And if you want to make a cross-platform game, a game like Sonic Heroes, okay, this was a game made after Sega went third-party. They stopped making games for their own console. They started making them for Nintendo, for Sony, for Xbox, all that stuff. This engine was very diverse. It could handle games like Sonic. It could also handle games you might have heard of like Grand Theft Auto, okay? This was an engine that was an absolute workhorse. It was very common that you'd see that renderware logo show up when you launched a console game in the 2000s. It was initially created in 1993. It was made by Criterion Software, okay? They are famous for the Burnout series of car and racing and destruction games. And they were acquired by Electronic Arts in 2004. I think they've been taken out behind the shed by EA since. I don't remember. Their output is not, I don't think it's super deluxe or super heavy these days. But as of 2023, it is officially defunct. I found a really nice little documentary on it. It's not very long, so I think we're actually going to watch it, okay? And this will give you a good feel for what renderware meant to that era of gamers and also that era of game developers. Let's take a look. Okay.
These games all have something in common. They're 3D engine.
More than 250 studios used it, and at one time it powered a quarter of all new console releases, helping to define a generation of games. Before Unity and Unreal, renderware was the little engine that could. But its dominance was short-lived. In 2004, it was probably the most popular game engine in the world, but 2 years later, it was effectively dead. How could something fall so far so fast? What went wrong with renderware? Originally, the renderware engine was neither a product of the games industry, nor aimed at that market. It was created by the camera company Canon at their European research lab. They spun it off into a subsidiary, with the aim of licensing the engine for applications like computer-aided design and virtual reality worlds. An early profile in Edge magazine sang the technology's praises in terms that verged on the hyperbolic.
Hard-nosed PC and IT correspondents at the launch couldn't believe what they saw was being generated in real time on a 486 portable PC. A new generation of software is around the corner.
But let's put this article in context. This was still the Windows 3.1 era. There was no DirectX, and OpenGL hadn't yet made it to home machines. Desktop 3D was something you only saw on Silicon Graphics workstations, or in movies. As well as the core group of developers creating the engine, the company soon started a small game development studio to apply that technology. Their role was twofold: producing commercial games designed to show off renderware's potential, and giving practical feedback to the engine team, so that they could tailor the toolkit to developers' needs. These early games, released on the PC, with a couple also on the Dreamcast, weren't particularly successful for the company, but games were just their side business, and they got some interest for their engine out of it. But though their early focus was on the PC, their breakthrough would not come on that platform. It was with the launch of the PlayStation 2 that renderware found its market. The machine's architecture was complex and unfamiliar, and writing code to display a simple 3D scene required a high level of expertise. Interfacing with renderware's libraries rather than the hardware itself was a considerable time save, trimming the company claimed 6 to 12 months from a typical development cycle, and with the engine also available for PC, Xbox, GameCube and PSP, it made multi-platform development much easier too. Renderware was far from perfect. The convenience came with a performance hit, and it could be frustrating to work with, but the trade-off was often worth it. It was relatively affordable, so even a small team could get in on the action, and it was extremely versatile. You could build a sports game, a shooter, a strategy game, puzzler, platformer, RPG, flight sim. There were even 1 or 2 MMOs. Renderware-powered titles number in the hundreds, and include generation-defining games like the Tony Hawk series and the GTA 3 trilogy. As the company grew, the games they produced internally improved far beyond mere engine demos. To the public, making games was what the company was known for, and it wasn't long before the accountants thought so too. With the success of their destructive arcade racing series Burnout, they were now making more money selling games to the public than from selling tools to game developers. This combination of marketable entertainment and coveted technology was irresistible to buyers, and in mid-2004, Electronic Arts bought the company, which if you haven't worked it out was called Criterion, from Canon for $48 million. The acquisition sent shockwaves through an industry heavily reliant on renderware. Hundreds of studios, including Sega, Sony, Microsoft, Ubisoft, Activision, Rockstar, Konami, and Capcom, had renderware games in development, and overnight, it was owned by their biggest competitor. One magazine described the story like this:
Electronic Arts buys the road that they're standing on.
EA pledged that support for renderware would continue uninterrupted, but studios were nervous about handing money to their biggest rival, and there was a trust problem too. Would the new owners really supply their best technology to their competitors? The CEO promised they would, but skeptical customers looked to switch to alternatives as quickly as possible. Before the buyout, Criterion had demonstrated the next generation of renderware, version 4, which promised to do for the Xbox 360 and PS3, while version 3 had done for the PS2. But the industry's concerns were proven correct. Updates to the renderware website ceased almost immediately. All talk of the new version stopped. Before long, EA terminated the licensing program, switching renderware to support mode for existing customers. Soon after that, it was described as effectively dead. And then, the final nail was hammered into renderware's coffin. EA licensed the Unreal Engine for its projects. Once the first choice for cross-platform development, renderware never made the promised leap to the next generation. Epic's Unreal Engine would fill the vacuum it left behind and become the market leader on the PS3, the 360, and beyond. We don't really know what EA's intentions were towards renderware. Some speculated that they bought Criterion to get their hands on the studio's IP and expertise in racing games, that they didn't care about renderware and deliberately killed it off to hurt the competition. But there's evidence that wasn't the case. Of course they wanted the Burnout franchise, but they also, it appears, had big plans for renderware internally. They spoke publicly about deploying an enhanced renderware 4 as the common technical infrastructure across all of their studios. But despite their best efforts, Criterion's team were unable to keep up with the rapid evolution of the Unreal Engine. Renderware's capabilities were surpassed, and EA cut their losses, spelling the end of the technology and the team of talented engineers that had created it. The days of game development in renderware are long gone. It's been 6 years since the last game, a Chinese mythological RPG, was released on the engine, and over a decade since the last major title, Persona 4 Golden, hit the shelves. I found only one place it's still in use today, powering one of the longest-running 3D online spaces, Active Worlds. And apparently, Criterion's racing game pedigree is also a thing of the past. The founders left, a promised open-world vehicle game was cancelled, and the company was cut to less than 20 staff before being rebuilt in a different form, a support studio for other EA projects. They didn't even handle the recent remaster of their own Burnout Paradise, but EA recently announced that the studio, now employing over 100 people, was working on a new installment of the Need for Speed franchise. So while it's not really the same place anymore, maybe we haven't seen the last game with a Criterion logo. Criterion's Burnout games have never been forgotten. But through renderware, the company had a hand in many more favourites, helping to make that console generation the success that it was. Their work was critical for reducing barriers to development on the PS2, and I don't think they're appreciated enough for that. If things had gone differently, Criterion could have remained a major player in the game engine space. Perhaps with the right investment, the right decisions, and a lot of good fortune, renderware might have been a rival to Unity and Unreal today. But that's just a fanciful what if. Renderware was the 3D engine that changed the world, but got left behind in the process.
Right? Really nice short documentary. It is definitely kind of a sad case, and it has to be said, when corporate stuff happens, right? When you have acquisitions happening, there can be a lot of interesting fallout from that stuff. So renderware gets purchased by EA, right? And suddenly everyone who's using that technology is very, very nervous. Okay, that can be enough to kill a technology and future plans for it, and it can turn into a kind of death spiral. Engine can't get resources because people don't want to use it, and because it can't get resources, it can't improve, and no one wants to use it, right? So it's a bit spooky. One thing I noticed in this video that I really liked is something we're actually going to do today if we have time. The team at Criterion had a great engine. And one of the reasons it was great, especially in the early days, was that they were using their own engine. They had a side of the company that was building games and being very serious about trying to sell them and do a good job. And thus, the engine developers had a very strong link with the people using the engine. And the people using the engine for cool stuff had a strong link with the underlying engine developers. And so that relationship is really, really important, okay? Have you ever heard the term dog fooding? It's the idea that when you're building a technology, you need to use it. If you are building a new email client to compete with Gmail, you should probably use your own email client and not Gmail. You should use Gmail from time to time so you know what the competition is and know what people expect in an email client. But if you are building an engine but you never use it yourself, it's probably not gonna be as good as it could be. Okay, so this course is not a game development course. This is not an EECS 494. Okay, you know what would be really crazy? Would be really crazy is if we required all 494 students to use the game engine you made in 498. Ooh. All right. That would be pretty exciting, huh? Yeah, I might not be teaching much longer after making that choice. Anyway, but at programs that have a dedicated game development major, that's actually the kind of thing that you can do. Because you can have everyone go through a required course, like a game engine architecture course. And then on the other side, you can make the assumption that everyone has their own engine, okay? And that all engines meet a certain standard API because they went through that course. So anyway, kind of interesting to think about. Renderware had kind of an integrated engine experience. It had some tools, right? Renderware Studio, which you can see right here, that allowed you to go in and kind of visualize your 3D scene and alter different actors and give them different attributes, okay? It allowed you to animate and analyze assets. It had an internal scripting language called RWX. I don't think I have a good link to it. There's some of that in here. I think it's kind of like a C variant or something like that. But it's kind of a scripting language. But the engine itself, it mostly seemed to be dedicated to rendering logic rather than dealing with things like inputs and stuff like that. Renderware Studio 3.7 is available on archive.org. I'm not sure if you can get this running or not. If you do, maybe and bring it in and show us, maybe I'll give you some extra credit or something. Okay. Kind of cool. To see that old software. All right. Okay. Does anyone have any comments or questions? Okay. Good. All right. Well, let's get to some announcements here. I found a really nice article, historical article by Jimmy Maher in Denmark. on the creation of Half-Life, the introduction of Half-Life. So Gabe Newell, right, and I believe, who was Mike Harrington, going and founding Valve. They'd been working at Microsoft at the time. They noticed the success that Doom and other first-person shooter games were having, just massive success. One of the incredible stats cited in the article is that at a certain point, Doom was the most popular piece of software installed anywhere in the world. It was more popular than Windows. So it's pretty amazing. But Doom really didn't put a whole lot of emphasis on its story. And when it did tell its story, it did so in these kind of cuts, right? You would get a little bit of story text in between missions or at the end of the story at the beginning, and that was it. There wasn't much storytelling kind of in the game itself. And every time it tried to tell a story, it had to remove you from the gameplay, okay? In that era, a lot of games did their story by basically leveraging other mediums. For instance, text, right, which you get from novels. It would tell its story through cutscenes, which they borrowed from the film industry. Half-Life wasn't the best shooter around, okay? It wasn't the most creative shooter around. It didn't have the world's best story in a game. But what it did have was a seamless story. At no point after clicking Start Game on the main menu does the game ever wrestle control away from you, okay? Everything, and I believe I'm getting the term right, is diegetic. You only see the things Gordon Freeman would see. You only learn about the story and things that are happening through his eyes and ears, okay? And so it was considered one of the most immersive games of its era for the way that it did not interrupt you to divulge its story, okay? Anyway, a lot of interesting details in here. It's a fairly long article, but it'll go by fast. And there's some interesting game engine things as well in there because they had to use the Quake engine, and that had some limitations, right? They wanted to build a gigantic world that was seamless and continuous. How are you going to do that in a game engine that is primarily made for small maps, right? Very, very cool article. The NeuroVR Laboratory is seeking a Unity and VR developer, and Dr. Krishnan sent me this last night, like 2 a.m., okay? And we had a nice conversation, as academics do, at 2 a.m. If you haven't seen NeuroVR Lab, this is a lab that is very impressive. It's a lab that basically led to the creation, or at least partially inspired the creation of EECS 440, our XR course. And this is the product they have. They have a rehabilitation framework that has a lot of mini games. You step into a virtual reality world made in Unity, and there are so many things you can customize that a doctor can prescribe mini games to a person who needs to regain, for instance, their sense of balance, or they have a medical condition where they don't have good motor controls of their fingers anymore. Well, NeuroVR is a tool that helps people rehabilitate themselves, exercise their limbs, and doctors can get data out of it so they can kind of track your progress over time. So super impactful, very human use case for these things we're learning, okay? In particular, they're looking for Unity developers, and they are looking for people who have some experience with VR. And if you only have one of these, you're fine. If you have both, that's a really good thing. But I'm sure they'll be excited to hear you've made your own game engine as well. Okay? In any case, yeah, super cool team. If you want some cash over the summer, if you don't have an internship or a job offer yet, if you want a letter from Dr. Krishnan for graduate school, okay, you can get one from me. You can get one from Dr. Krishnan, and then that is 2/3 of the way to graduate school, okay? You typically need 3 letters for grad school applications, and there's 2 of them right there. Okay, so anyway, definitely a cool opportunity if you're looking for one. A red alert, this is not a drill, but we have a student in the course who has reached 98% plus on homework 7. The student knows who they are. This is the same student who hacked the homework 6 test cases and led to those getting upgraded in the new policy, okay? So this is all to say that, we got some amazing students in this course. Okay, keep your egos in check, all of you. Okay, you're amazing, but you'll perform better if you assume that's not the case, and you'll keep growing and learning more. All right. But in any case, what this tells me is that homework 7 is not the terrifying monster that it can sometimes look like. In particular, homework 7, if you can get past the first 2 test cases, you're going to start to steamroll the test suites. Okay, let the bodies hit the floor; they're going to fall like dominoes, and you're going to feel really good. Okay, I hope the student who has gone ham on this assignment enjoyed the assignment as I look to the back of the room. I think you're all going to enjoy it as well. All right. So anyway, blah, 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 blah. Okay. A note on engine design. You won't feel this quite as much as I did while I designed the engine myself with the specs and all that. But this might be one of the first times in your programming career where your user is actually another developer. And that's kind of a very interesting, powerful thing, right? We usually make games or software for an end user that doesn't really know much programming, that isn't a technologist like we are. But in this course, as you make this engine, you have to constantly be thinking about how is my fellow programmer going to use these cool things I'm making for them. So, right, especially in the final couple weeks when you are doing your custom feature, you might have to think about your API design. You might have to think, I'm going to build this cool new chunk of technology. What is the easiest way that I can help other people use it? Okay? And so it's a very powerful feeling, and I hope you enjoy it. I'm going to show you this famous clip of Steve Ballmer. On homework 7, this is how you should be thinking. If you want to get homework 7 to 98% in just a couple of days, this is how you have to feel in your heart and soul, okay?
Developers.
Yes.
I can't tell if that's saying we're supporting developers or we're about to take down the developers.
Yeah, maybe. Yeah. If you know much about the Steve Ballmer era, it's kind of like, it's hard to say. Anyway, okay, so let's go ahead and talk about implementing a component architecture in your code base. We talked a little bit about how this can be done generically in C++ during our composition lecture a few lectures ago. But that was making a component architecture all in C++, i.e. the components are C++ components, okay? That is not the case in our homework 7. In homework 7, we have a difficult challenge. We have C++ core that is trying to support a series of Lua-based components, okay? And so the interaction between these two languages is something that is a bit tricky. Fortunately, we have a ton of sample C++ code in this lecture for you, okay, and in the assignment spec as well. So let's go ahead and talk about that, all right, and show you some. Okay, so components, right? Hopefully by now you're getting a feel for what they are, even if you haven't taken 494 or 440. Components are a big thing, and hopefully it's not too scary right now, okay? But just in case you've forgotten what components are and how a game tends to be structured, basically it's containers all the way down. A game, okay, if you think about all the things that comprise a game, well, a game is a series of scenes. You might think of a scene as a level or a map, right? Remember the theater motif, okay? But we have multiple scenes in our game. Each of these scenes is going to have multiple actors, okay? Again, the theater motif. But what is an actor? An actor is a container for components, okay? So we have a game, which is a container for scenes. Each scene is a container for actors, and each actor is a container for components. This is all starting to feel really recursive, doesn't it? As if they could all be one data type. And if you've ever explored Godot, you'll know that they felt very similarly because the Godot, the way that Godot is structured is that basically everything is a node. Even your levels are a node, okay? Your actors are a node, and if you set up a component architecture, your components are nodes, okay? It's nodes all the way down. We don't quite go that far in this course, right? Actors are different than components, right? And actors and components are different than scenes. But in any case, right, if you look at these components right here, C1, C2, these actors can have as many or as few components as they want. They could also have none, all right? They could have none. And each of these components are going to be Lua tables. They're going to be Lua tables that derive from a base Lua table, i.e. a type table, a component type table, all right? Up here, we have 3 different components that exist in this game. Donna, if you remember who Donna is, it's the donut pilot from the start of the course, okay? You're going to be seeing her again on homework 7, by the way. Keyboard control, which is a component we can slap onto anything, and it will start to move when we use the keyboard. And let's say HUD. This is a component as well. Each of these components, each of these tables that are inside of our actors use inheritance to get their type, okay? So C1 might inherit from the Donna component. C2 might inherit from HUD, okay? These over here might inherit from Donna and keyboard controls, okay? This actor 1 is probably the character we're moving around, all right? Okay, so a question on your mind is, this is great. You hopefully conceptually understand how this is all set up. But how on earth do we implement this in C++, in our actual code base, okay? And you might be very intimidated, right? I will tell you, when I got rolling, designing and testing this engine, it was difficult to know where to even begin, okay? And I'll say last year, a lot of the students beginning homework 7, this were basically them, right? These are the vibes. I think in part because for whatever reason, I'm like the only person who enjoys cutting all my homework 6 code. Like, I just didn't like it very much, and I got rid of it. And it's like, yeah, delete. Oh, it's so elegant now, right? And yet, most of the students I talk to are like, oh, Austin, I put so much effort into homework 6, and now it's all gone. And it's like, I guess people really like their homework 6 code bases and the games you can make. I still haven't seen someone make an actual game and say, hey, Austin, play this. I made new characters. I gave them cool dialogue. I made some levels. No one's done that with their homework 6 code base. And if you haven't let me play it, which you should. Yes?
I think it's the feeling of, especially for fighting Suite 6, you spend all that time hunting down the nodes, going ops out.
Yes.
Figuring out how to make it super fast.
Yep.
And then a couple of days later, oh yeah, all that effort, we're throwing it all out.
Yeah, it's gone. Rest in peace. Rest in peace. Well, that's the kind of stuff that like someone who's writing Box 2D has to figure out, right? We're not going to write Box 2D in this course. We're going to use it. But in any case, we need to establish, and by the way, if you're just starting homework 7, you have no idea what to do, this is the first thing I recommend you do. It will give you some clarity, okay? Establish some component type tables. Remember, in Lua, everything is a table. Your component types are tables. Your instances are tables, okay? Everything is basically a table. And one of the most powerful things you can do early on is to look at what types are available in my project. Basically, you're going to look in that cool resources folder, which I just happen to have one of right here, resources. You're going to go into component types. Look at all the Lua scripts that exist in your project. Load them in. All right, load them in. These things, okay? Donna, keyboard control, HUD. These are your components, and they're all in a file, all right? Okay, and so, right, in resources, in component types, you're going to find all of these .lua files, okay? In these files, you're going to find one table apiece. And remember, the table name must be the exact same name as the actual file, okay? This can make some of your coding actually a bit easier if you remember this fact, okay? Component types are just tables, all right? So right here on our right, I'm going to show you how the Lua state evolves as you run certain lines of code to kind of set things up. Now, if you recall, when we did that example last time, we run code, we create tables, and our Lua state is going to fill with variables, okay, and tables and all that good stuff. So let's say that we have Donna here, a component called Donna, a table called Donna. Well, we want to run this Lua code. Why? Because when we run this Lua code, it's going to create that Donna table. Donna is going to be a table in our global Lua space, which means we can use it. We can reference it. We can mess with it. You don't want to do that, though. And so we're going to run this code. Well, how do you do that? Well, Lua provides some really nice functions that make this trivial, basically. Okay? Here's a function for you. Lua underscore do file. Lua L do file. All right? What do you send in? Well, you send in a reference to your Lua state, okay? And then you send in the actual file path that you want to load. It's going to load in the file, and it will return you a value. If it's not Lua okay, then you need to print a error message and exit, okay? But this function right here is going to run this code, and it's going to affect this particular Lua state that you sent in. In your engine, you will only have one Lua state, okay? Never think that you need two, all right? You'll only have one. Some games, some applications like Wireshark might have technical reasons they want to have multiple Lua states, but that does not apply to us, all right? So anyway, here's what happens. You run this file via the Lua-L do file function. This Lua code gets run in your Lua interpreter, and thus our Lua state suddenly has a Donna table inside of it, all right? It's just chilling there. Okay, it's a global variable that we can reference via that Donna with a capital D. All right, so that's a good start. Well, it turns out there are other Lua scripts in our component types folder as well. And if we run that do file function on all of them, we won't have just one table named Donna. We'll have a bunch of tables, actually. We'll have one table that exists for every component type. These are not component instances, right? We're not slapping these on our actors. These are just the possible types of components that can exist, okay? And so keep that in mind. And so we've got, yes, oh, by the way, this looks a bit like a stack. It's not a stack. This is just a key value store, okay? All right, so a question is, how do you reference and manipulate these tables? Well, here's what you can do. Lua Bridge provides us with a really convenient data type called a Lua ref. In order to use it, you do Lua Bridge : Lua ref. And this is basically a data type that can contain any Lua thing. A table, okay, a variable, a function, okay, whatever you want. And if we want to get something that's on the highest level of our Lua state, a global variable, you can use this Lua Bridge function to easily do so. Lua Bridge : get global. You have to send in the Lua state that you care about, and then you have to provide a name. What is the name of that global thing that you want to grab? Okay? By the way, is this an object-oriented style of programming? No. Why? How can you tell? Yes?
Because you're passing in a pointer to the Lua state instead of that being a member function of the Lua state.
Bingo. Absolutely. Absolutely. So if this were object-oriented, if this were kind of a more modern, typical library, you would have Lua state as a variable, okay? And when you did dash caret, okay, for the pointer, it would autocomplete and you'd see a function like getGlobal on it, okay? That's not the case here, which is a strong hint that this is kind of a bit of an older library, possibly, okay? Or maybe the person who wrote this library just really likes C and not so much C++, okay? In any case, it works, so you'll be fine. What is a Lua ref? A Lua ref is a reference to a thing. It's a variable, a variant type that can store many different things. For instance, here's a really useful line of code that puts a new table, an empty table, into a variable called new empty table. This is of type Lua-ref, and so this is how we can kind of reference and manipulate and deal with Lua things in the C++ side of our code base, okay? So as soon as we run this function right here, watch how the Lua state evolves. Suddenly, we have an empty table in this Lua state. Now, this empty table doesn't have a name. It's kind of an anonymous table, okay? But we can still work with it and reference it thanks to our C++ variable right there, okay? So we now have a Lua-ref variable that represents a new table, okay? Now, here's something really cool. You can take a Lua-ref representing a table. Let's say it's called cool table now. And you can say, well, I want a reference to a function on that table, okay? Let's say that we have a function called onUpdate on our table. Can any of you think about why that might be the case? Why would we ever have a table called a table that has a function in it called onUpdate? Yeah.
If the table's a component.
Yeah, if we've got a table, if cool table is one of our components on a particular actor, then we want to grab that onUpdate function because we got to call it. We got to call it from C++, okay? And so here's how you can do that. You can take a Lua-ref, you can use these little indexer square brackets, and you can just put the name in of something in that table, and if it exists, it will provide you that reference, and you can just store it, okay? Once you've got this Lua reference representing a function that is on a table, okay, you can do things like this. You can take that variable onUpdate function, you can do dot is function, and this will return true if this Lua-ref is representing a function. If it's representing something else like a table or a number or even nil, which i.e. null, then it will return false, okay? Otherwise, you can run the function by using the open and close parentheses like you would a normal function, okay? One thing I'll say, though, is that be careful about Lua functions. If it's a static function, you can just do this. If it is a member or instance function, then a reference to self is necessary and we must provide it, okay? So you might need to pass in a variable into your function. That variable might be itself a Lua-ref, okay? And so there you go, calling a member function, providing self. If you don't do this, you're probably going to get some null or nil indexing issues, okay? So you're going to want that. All right, so it's a reference to a Lua thing. You can also describe Lua-ref as a variant type. Variant types, you find them in many different places. You tend to find them, well, first of all, it's a universal type in dynamic languages, okay? In languages like Python or JavaScript or Lua, you just say my variable equals thing, and it will just encase that thing, all right? In a statically typed language like C or C++, or even C#, you usually have a specific type called a variant type. If you need a data type that can hold anything, like an object, a generic object data type, okay? You then often have functions like the, is Boolean, is function, is table, that can help you understand what is in that variant type, because you don't know just by looking at it, okay? If you look at all the cool functions that the type has, the Lua-ref type has, it has a ton that are basically dedicated to helping you check what is in here, because anything could be, or nothing, all right? Okay, so here's a really important part and something that's of grave concern to you. You have loaded in and gotten a bunch of table types into your Lua state. That's awesome. These are a bunch of tables. Each one represents a different type of component that you could instance onto your actors, okay? We could have an actor that has 5 score counter components, or none. Or maybe it has 1 has health and 1 keyboard controls, or maybe it doesn't, okay? Well, we don't want to mess with these tables you see right here because these tables represent the underlying type of component, okay? These aren't the actual components that we slap onto actors. No, we're going to create those. We're going to use these base tables to do so, all right? So we're going to create instances like this empty table instead, and then we're going to tell this instance to inherit from one of our base tables, okay? Here's how you do it. You run this line right here in order to create an empty table, okay? This is equivalent, by the way, to running this line of code in Lua, okay? You just created a new table. It's empty. This table's not a component yet. You have to do something more to turn this table into a component, okay? This empty table, we want to be an instance of Donna, let's say. This is going to be a component. It's going to be a Donna component. It's going to be an instance of the Donna component type. So what we're going to do is we're going to have this empty table, this new empty table, inherit from this Donna table, okay? And that is actually going to be what creates the instance style behavior that we want. Last time we used the topic of metatables to create new instances of the enemy class. You remember Goomba and Koopa, right? It's a bit of a mess. It's hard to understand in Lua, so it's going to be a mess to understand in C++, all right? For this reason, and because we are not really a deep dive on Lua course, we provide you, the instructional staff provides you with a component with a function called establish inheritance. What it does is it takes an instance table. This is your empty table, okay? And it also takes in a parent table. This parent table is going to be one of your existing type tables, okay? And it's going to establish inheritance such that the instance table is a new instance of that parent table, okay? And so, right, you just use this code. Now, we're all engineers, so even though this code is kind of gnarly and we just give it to you, you probably want to understand it, okay? This is not going to show up on the exam, but to pique your curiosity, we'll give it a shot, okay? So what we're doing here is something you've definitely seen before. We're creating a new empty table. We're calling this a new meta table, but it's just a table, okay? And so this table is going to have a variable called __ index. If you recall, this is going to make the table pretty special, okay? This table, this index value on the table is going to point to the parent table, and this makes the table possible to be injected as a useful meta table, okay? So how do we set a meta table with the raw Lua API? It's a mess, okay? All right, some people watching, because these are all on YouTube, someone's going to see it. Someone super old school is going to see it, so it's not a mess, all right? What we're doing here is we're taking our instance table, okay, and we are basically pushing that instance table onto the Lua stack. We're then pushing a second thing, the meta table, onto the Lua stack, and then we're going to call Lua set meta table. And we're going to give it our stack, okay? I think -2 says, hey, look 2 down on the Lua stack to find the parameters you need. What we've just done here, okay, what we've just done here is we've just done this line of code, okay? We're setting a meta table, and the reason this looks so weird and requires 3 lines of code is because this raw Lua C API, it's based off assembly programming, okay? When you want to call a function in assembly programming, you have to basically put things on the stack, and then you can call it, and then it'll use those things, okay? You have to put it in the right place on the stack, and there you go, all right? So yeah, here we use the raw Lua stack to pass parameters to the Lua library functions, and this has nothing to do with the Lua state, and is from my perspective a bizarre design choice. But basically, we're using kind of an assembly style approach to parameter passing here, okay? And it's wild, okay? But in any case, when you look at all this code, everything happening here in C++ is just doing this up here, okay? We are creating a new table. We're setting the meta table. We're returning well, we're not returning the instance, but this instance is now all set up for future use, okay? So there you go. Here's the situation now. We have an instance table. That empty table is now instancing Donna, okay? And we can now use it. We can now attach it to actors. We can do whatever we want, all right? So there we are. It is a brand new component, genuine component, not a type of a component, okay? So we probably want to store this as a Lua ref inside of an actor, right? Because actors are containers for components, okay? You might ask yourself, well, what container should I use to store my actors? What container within the actor class should I use to store my components, okay? You might say, well, you could start with doing, hey, I'm going to have an STD vector, and this is going to be of type Lua ref, or a pointer, okay? So you're not copying Lua refs all around everywhere, okay? Would you use that? The answer is probably not, okay? But I can't give away the entire assignment, so I will ask you to think about, are there certain features that vector might be missing that we really want for our components, okay? For how we store and manage and organize our components, okay? All right, so just think about things like, how fast do I need to get to my components to mess with them? How do I want to access my components? By an index, by an integer, or by something else, like maybe a string, okay? Are there any data types you know of that have these properties, okay? And maybe that's going to be a good call to at least start with, but experiment a bit, okay? So when it comes to Lua refs, right, we're in C++, we've got a Lua ref that represents a Lua table or a Lua function or whatever. Well, sometimes we want to edit a Lua table. We want to edit a component from C++, all right? How do we jam things into our components, into the world of Lua? Well, here's an example, okay? I don't think this is a super good example because new component instance isn't set up, so I don't think this is going to work. I don't think it's a table. But what you can do, if you have a variable like an integer, is you can take a Lua ref, say representing a table, and you can give it a name in Lua and then inject that value. So after this line of C++ code runs, any Lua code that tries to use the cool variable will find that it actually exists and it actually has a value of 494, okay? So you can do that with integers. You can do that with strings, okay? Here, EECS 440 is getting plugged in to the table, and it can now be used from the table, okay? Do you remember why we'd ever want to do this? Do you remember overrides? You remember overrides, right? So this idea that we're going to have all these Lua components, but guess what? Sometimes in the JSON, okay, we're going to have variables like X and Y that we want to jam into. We want to inject into the transform component to change, for instance, where we start the game. Same thing with sprite render. We've got an image that we want to render. Well, we're going to define which image in the JSON, not in the Lua, okay? And so, we need this ability. But can you inject other things, okay? Integers and strings are pretty much universal data types, even across languages. But can we inject even a custom class? Like, if you have an actor class, can you inject that into Lua from C++ and have it just work? The answer is actually yes, okay? Here's a more simple example, all right? Let's say that you have a vec2 class. This is just a simple C++ container that wraps an X and a Y, a 2D point, okay, a vec2. Well, you can register that vec2 data type with LuaBridge, okay, using this code. LuaBridge get global namespace, provide your Lua state, so we know which Lua state we care about. Then you can go .begin class. You template this on that vec2 type. So in this case, we're making the GLM type available to Lua, You then give it a name. In case you want the C++ name to be different from the Lua name, you can do that, okay? You then have to tell Lua Bridge about what pieces of that data type you care about and what does it map to. So we're going to tell Lua Bridge that there exists something called a x, and by the way, that is the GLM vec2 x variable, okay, that every vec2 will have. You do end class, and that is going to register this C++ data type so that basically the Lua side of things knows about it. And you can use it in Lua. You can send it back and forth between the two languages. It's very, very nice, okay? And here's an example. We have a new component, a new table. We want there to be a variable called pause inside of that table. And so we're injecting it like this. And it is a GLM vec2. Cool, okay? What about functions? All right, well, you can do that as well. Here's a more advanced example where we have an actor data type. And by the way, this is something you will need to do on your homework, okay? You'll inject an actor data type of some sort that must be called actor. And then you'll add functions like get name of the actor, get ID of the actor. But sometimes when you have an actor reference, you want to get other components on that actor. And so things like get component by key, get component by type, get components, so return an array, i.e. return a table of all the components that you have of a certain type. Add component, remove component, okay? All these are going to be fun for you to implement. And Lua Bridge really speeds up our process, okay? So after you do something, after you set that up, it's all good. What about this function, debug.log? This is one of the first functions that you have to inject into Lua because debug.log does not exist, okay? Print the name of the actor this component is on. This line of code right here. Pretty cool. Okay, you have to make that line of code come alive, all right? Let's talk about static functions because debug.log is a static function. It doesn't have any sort of reference to self or to an instance that it needs, okay? Where did debug come from? Basically, debug is a table in Lua that C++ will inject into the global Lua space, and it has a log function, okay, that connects to a C++ function. Here's what this looks like. Get me that global Lua state. I want you to create a new namespace, i.e. create a new table, okay? Call it debug with a capital D, and then I want you to add two functions to it, okay? Add two functions. And by the way, when I call log, I want to call and pass all the parameters to this C++ function, okay? When I call log error in Lua, I want to pass everything to the C++ log function, a log error function, then end the namespace, okay? That function, if you're curious what it looks like, it's really simple. All it is a function that takes in a string by reference, and it just prints it using cout. Nothing crazy, okay? So, dealing with actor templates. You remember actor templates from homework 5, right? Homework 4, in fact, they were introduced in. It is a super important feature. You can't really build anything quickly if you don't have it, okay? It's a very tricky feature in homework 7. You're going to need to be careful about how you process a JSON file, and you're going to need to be careful about how you decide, do I need to add a component here, or do I need to just edit one that already exists? Okay, that's a difficult question. And a hint is that you can use the key that each component is guaranteed to have to know whether this is a new component or whether it's the same component being edited. Okay? So anyway, you'll get a feel for this as you get deeper into the test cases. And if you choose the right data structure, this is actually super easy. It's something to think about. Okay, this was actually the hardest part of designing the engine when I was making the course. I didn't know an elegant way to let a game designer decide when they are overriding variables whether they are overriding a component that already exists on the prefab, the actor template, or whether they're adding a brand new component that sits alongside a component from the actor template, okay? It's an ambiguous situation, but we ended up resolving it in a very elegant way. So you might want to think about it, okay? Okay, a challenge. How does the following code fail? This is C# code, by the way, but you should be able to mostly gather what it's doing, okay? The following code will fail, all right? It's not even going to finish. And yet it's such simple code. Where could the error be? A little bit more time to look. Okay. Bingo. Yes, yes. You are altering a container while you are iterating through the container. Okay? So here we have this container, a dynamically resizing list. Okay, this is basically C#'s version of std vector. Okay, list. We got all these courses here. We're going to iterate through all those courses in a for each loop. That's just fine. When we detect that we've hit EECS 498, we're going to remove EECS 498 from our container. But you can't alter the container or its contents while you are iterating through it. In C# at least, this will blow you up, okay? And you see this, invalid operation exception. The collection was modified, okay, at the wrong time. So, how are we going to deal with this, right? You can't modify a container while iterating through it, but we still want to remove that course when we find it, okay? Now, you might think, well, wait a second, let's use an index-based loop, okay? Currently, this is a range-based for each loop, so let's just use a normal for loop, okay? All right, we got new code. Excellent. How's this one going to go? Poorly? How could it be? We're iterating through until we find the course we want to remove, and then we are just removing it, very simply, okay? We're moving that index, and then we keep going, right? What's the problem?
I believe you hit an out of range error since it doesn't detect the count.
I don't think we hit an out of range error, but that's close. It's close. What's the problem? Yeah.
I think you'll end up skipping elements.
Bingo. Okay, here's what happens. All right, here's what happens. And this might show up on the quiz, okay? Be careful. We're going to iterate through. I is 0, so I is a pointer to EECS 498. As soon as we see that, hey, we're looking at EECS 498, we'll remove this index. So this is now gone. EECS 498 is gone, but every element has been shifted upward, okay? And so now 0, I equals 0 is actually pointing to EECS 494, okay? When we run continue, I is going to go to 1, but 1 is now going to be EECS 440. So my beloved 494 just got skipped, okay? Just got skipped. And if you run this code, this is the result. Yeah?
Right, so what's stopping you from just throwing in an I minus wherever you remove something?
Bingo. Let's do it, okay? How are we going to fix this? Well, whenever we remove something, right, we have to kind of back up the truck, okay? So here's what we've done, right? I minus, okay? And this kind of fixes it, okay? Right? We get the result that we expect, but yeah, it's kind of nasty, right? It doesn't feel very elegant, okay? People are going to wonder why you're doing this, okay? It's not super intuitive why you're doing this. Okay, not super great. Is there a cleaner fix here? And the answer is yes, all right? Something that's very common is the collect then alter pattern, okay? And this is a pattern you can use to remove things from a collection after you're done iterating through it. It's a very simple pattern. Here's the basic idea, okay? It's a bit more code, but I think it's actually cleaner code and easier to understand. If we're going through this container and we know we want to remove things from it, what you can do is you can create a secondary container just to track which things we want to remove. We then iterate through, okay, everything. And we're kind of marking, okay, anything we want to remove. We're basically saying, oh, hey, we want to remove this course, so let's go ahead and store the index that course is at. And then later we're going to remove it, okay? Down here, we've finished iterating through everything. We now know every place we want to remove stuff, and we're going to remove those indices, okay? Something interesting to point out here is that the way we're iterating through this removal container is backwards, okay? Why? Yeah.
Since otherwise you'll skip things again, I think. And or I guess it'd make you remove the wrong stuff then.
Yeah, yep. So what happens here is that we need to iterate backwards, okay? Otherwise, we may very well, we're going to remove something from our initial list, but by removing something, we've just shifted all of the indices. So now we will move the incorrect thing if there's ever more than one thing that we want to remove, okay? So what a mess, right? I mean, it's a little bit weird and a bit surprising. This is probably a cleaner still approach, okay? I like this one a lot. This is no longer storing indices. This is storing the content of the thing that you want to remove, okay? And so now we don't have to iterate backwards through that removal array. We can just remove it by its content, okay? And this is less performant, but quite a bit more pleasing, okay? And so I would tend to use that unless I had a reason not to. So, a question, why on earth do I bring this up in the middle of a component-based C++ lecture? Well, look at this right here. This is about the most homework 7 code I'm going to show you. Okay, you can use this if you want to. Okay, what is happening here? This is an update function on an actor. When the actor updates, it needs to run through and update all of its components, okay? And so it's going to do that. Well, it's going to grab the onUpdate function here, and if we're enabled, if we can do it, we're going to call that onUpdate function, okay? An actor's job is to run through its components every frame and call the necessary functions. One of those is onUpdate. By doing so, every component gets to have its onUpdate function run every frame, okay? And so this is great. But what happens if you run this onUpdate function and a Lua component during the update tries to get rid of another component in your component container? You've just run into the same issue we were just showing you, where we're iterating through a container and something in that container causes us to alter the container, right? You do not know what the user is going to do in that onUpdate function. You don't control that anymore. It's up to the game designer. It's up to your user to write that function. So what are you going to do? How are you going to make sure that this update loop doesn't explode in a fireball because the user decided that, on this frame, during my update, I want to remove a component? What if a component tries to remove itself? That can happen. That's a thing that can happen, okay? So anyway, we're iterating through components, and onUpdate could result in many different things happening. We could add a component. We could remove a component. But what you need to be careful of is you need to find a way to let us alter this container without blowing everything up, okay? You must not alter the container or the collection while you're iterating, and so you'll have to think about how you want to do this. Another interesting thing here, you see this try-catch statement right here? Try-catch. You do not control this Lua code. This right here is the moment where we transition from your game engine code that you wrote, that you can fix, that you can control, into the user's stinky, nasty, buggy code, okay? If the user writes buggy code, your engine is not allowed to crash, okay? Your engine cannot crash. Your engine instead must protect this, right? Protect the engine, keep it running, and then you need to be a good engine developer and help your game designer out, help them fix their stinky, buggy code by reporting an error and telling them, hey, you've got an error, this is what the error is, and this is the line of code that the error is on, okay? You know when you get that error message in Unity, and it's like, hey, you've got this exception that happened in this component on line 62. Isn't that nice? What if the console message instead just said, hey, error? That's all. Just literally error in red text. Be like, oh, great, thanks. Right? Wonderful. And it's going to take you an hour to track that thing down instead of seconds. All right? So anyway, yeah. You really got to think about homework 7 like you are taking care of your developer friends. Okay? How are they going to mess this up? What kind of features do they need to do a good job? Okay? Your users are other developers now. And that's really kind of like that's not the kind of thing a junior developer or a student developer tends to care about, right? This really is the kind of stuff that like a lead engineer or like an engineering architect focuses on. So anyway, you're doing tough stuff. That's all I'm saying. Your component architecture, I think you'll find it to be very elegant. You might need to experiment a few times, okay? One thing you might try is just for now, just see if you can load up one component on one actor. You can write some hacky code to do it and get it working, and then you can generalize it and make it nice once you understand what's going on, okay? Make it all nice and fancy, all right? Pretty elegant stuff once you get into it, and I think you're really going to like it, actually. Once you get rolling, you're going to feel unstoppable, okay? Like, no joke, in like the span of like 24 hours, I think our student went from like 10% to like 98. It's crazy. Crazy, okay? All right, so I'm a bit torn, all right? What do I want to do here, okay? We got through this lecture. Now is when I would build a game with you, but I don't really want to do that because we don't have enough time to make it awesome, okay? So I think I'll show you let me see here. What is coming up? What are we going to do on Monday when we come back? When you come back on Monday, you're going to have 1 week to finish up your homework 7, okay? Hopefully you won't need it. You'll be able to relax. You all get to see a preview of what the engine of the day is for next lecture. You know what I'm going to do? I don't know if I'll show you Roblox. You know what I'm going to do? This is what I'm going to do. And coroutines are going to get pushed probably to the following lecture, okay? Or maybe even later in the course where they're needed for a homework assignment. Anyway, okay, I want to end a little bit early. Does anyone have any questions about any of this content or topic? How many of you have started? How many of you have gotten at least 2 test cases cleared on homework 7? How many of you have sent a homework 7 submission to the autograder? How many of you have looked in the assignment spec? Okay, rockin'. How many of you, and this is a little bit beyond the assignment spec, how many of you have begun hacking out parts of homework 6 to get your homework 7 ready? Okay? Okay, good. All right, good. I would encourage you, by the time spring break officially starts on Saturday, I would encourage you to try and get a little bit into that first or second test suite, okay? That's going to make things much nicer and less stressful for you when you kind of get back, all right? And should set you up really well to just knock test cases down like you're at a bowling alley, okay, when you come back from spring break, all right? I think actually that's all I want to do. Yeah, I'll find some more content to put in this lecture next year. But let's go ahead and start office hours. You get 20 extra minutes. If you want any help thinking about how to set all this up, hopefully this lecture is super useful to you. Feel free to refer back to it at any moment. Use the code that you find in here. And raise your hand if you have any issues, and I'll see if I can explain things. Okay? All right, everyone. I hope you have a safe, healthy, and happy spring break. Okay? You all deserve it. You're working very hard. When we come back, we're going to work hard again for just a couple weeks, and then we'll hit the exam. You'll have an entire week just dedicated to getting ready for the exam. Then the final 2 weeks of this course, nice, chill, okay? Do a good job, and then we will relax a bit and do some fun custom stuff that's easily graded, very nicely, gently graded, and you can focus on the other courses in that final 2 weeks a bit. Okay? All right. I'll see you later. Stay safe. All right, everyone online, I will see you later, okay? Take care. Have a good spring break. Bye-bye.